Did you know that the Pleistocene era was a really important time in Earth's history? It's when the last ice age happened, and glaciers covered a lot of the planet. This period of time lasted for about 2.6 million years, and ended around 11,700 years ago. What's even cooler is that modern humans, like us, had actually evolved during this time, and had spread all over Earth before it ended. There were also some really fascinating animals that lived during the Pleistocene, like woolly mammoths and saber-toothed cats. Unfortunately, many of them went extinct at the end of this era. Earth has had some pretty wild weather patterns over the last 2.4 billion years. Although the planet is mostly ice-free, we now cycle in and out of freezing ice ages. During these glacial periods, temperatures drop, and huge areas of the planet get covered in ice. It all starts with a bit of snow, which then builds up over time. The ice reflects sunlight, making things even cooler. The result? Vast glaciers that slowly move toward the equator, changing the landscape as they go. And when the ice melts, sea levels rise again, and everything changes all over again. In total, there have been at least 5 ice ages so far. The first one was so intense that the whole planet turned into a huge snowball. Right now, we're actually in the middle of an ice age, but we're currently in a temporary warm spell that started around 11,000 years ago. These warm periods are called interglacials, and we're not quite sure how long they last. There are still massive ice sheets covering Antarctica and Greenland that hold 75% of Earth's fresh water. When these finally melt, it'll mark the end of the current ice age. Earth's temperature is affected by something called the Milankovitch cycles. Basically, the amount of heat we receive from the sun changes over years, decades, and millennia because of Earth's orbit, tilt, and axis angle. There are 3 different patterns to these cycles. The first is called eccentricity, which is all about the shape of our orbit. The second is obliquity, which has to do with the tilt of the Earth. And the third is precession, which is like a wobble as Earth spins. Depending on where we are in these cycles, we might experience colder or warmer temperatures. But other things, like the position of continents and the atmosphere, also play a role in our planet's fate. For example, our planet's orbit is not quite circular. It's actually a bit elongated, shaped almost like an egg. That means we're sometimes a little closer or farther from the sun, depending on the time of year. We call the point farthest away from the sun the apogee, and the closest point is the perigee. When we're at the apogee, we're moving away from the sun, but gravity eventually pulls us back toward it. This means our orbit changes a little each time, gradually shifting our position relative to the sun. Don't worry, even though the orbit changes over thousands of years, it doesn't have a big impact on our day-to-day lives. Changes in Earth's orbit can affect how much sunlight we get during the summer. This means that ice sheets in the northern hemisphere will melt less, and over time, they actually start to grow. As they grow, they reflect even more sunlight, which makes the climate even cooler and spreads the ice even farther. This process can last for a really long time, like 10,000 to 20,000 years, and eventually it brings the planet into its next freezing season. As for the next ice age, scientists believe it might be postponed indefinitely. They've found that our human interaction with the environment, like the use of fuels, could delay the next ice age by up to 100,000 years. Earth's past ice ages were linked to the amount of solar radiation and carbon dioxide concentration in the atmosphere, and this research can even help us predict future cycles. It's amazing to think that our actions now could affect Earth's future for thousands of years to come. And while it's not really important when the next ice age begins, it's pretty cool to know that humans have the power to shape the future on a geological timescale. Ice ages have had a huge impact on our planet and human civilization. So it's fascinating to think how our actions now might change things, maybe even for the better. What did life look like on our planet during the last ice age, though? Well, North America, for instance, was home to some huge creatures: mammoths, saber-toothed cats, giant ground sloths, and mastodons were just a few of them. And get this, even Europe had an 11-foot tall flightless bird that weighed almost as much as a polar bear. Meanwhile, down under in Australia, there was a giant lizard that lived in all sorts of habitats during the same time period. Even though some animals from the Pleistocene era aren't around anymore, you might recognize many of those that are still around today. In Alaska, for example, you can still find brown bears, caribou, and wolves. People just like us actually lived through the Ice Age too. Our species, Homo sapiens, has been around for about 300,000 years. And we've spread all around the world since then. Some of our ancestors stayed in Africa during the Ice Age and didn't feel the full effects of the cold. And others ventured out into other parts of the world, even into the chilly glacial environments of Europe. Our early relatives, like the Neanderthals in Europe, and the mysterious Denisovians in Asia, were also around during this time. Although they seem to have gone extinct before the end of the Ice Age, it's pretty amazing to think about all those different hominids that roamed Earth during that period. What's also fascinating is how our species managed to survive the Ice Age, while some of our cousins didn't. Some experts believe that our adaptability, social and communication skills, and the use of tools played a huge role in it. And guess what? Humans didn't just hunker down during that time. We actually moved into new areas. Fossilized footprints found at White Sands National Park in New Mexico prove that humans have been in North America since at least 23,000 years ago. That's close to the peak of the last Ice Age. While a full-blown Ice Age might still be far away, there is a possibility of a mini Ice Age coming our way. Some scientists believe that in about 10 years, we might experience a significant drop in solar activity, leading to colder temperatures in the northern hemisphere. This could result in conditions similar to the Little Ice Age in the late 17th century, when the Thames River in the UK froze over. While scientists aren't quite sure what caused that cooling, it's fascinating to think about the potential changes. We've done it before, so we know that humans will most likely survive the next real Ice Age, even if we don't manage to figure out a way to stop the next freezing era. But it would come at a high cost. All the ice that would cover most of the northern hemisphere would have to come from oceans, which would cause the sea level to drop. This could mean more land for some countries, but it would also create other problems. Sea levels going down might seem like a great thing at first, but actually, it could lead to some challenges. Having been covered with salt water for thousands of years, the new land might not be very fertile. This means it wouldn't be great for growing crops, and we'd have to find other ways to feed ourselves. Back when humans first started out, there weren't many of us, and there was plenty of food. Now, with over 7 billion people on the planet, it's a different story. We'll need to be resourceful to make sure everyone has enough food to eat.
Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So, the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalus eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sundhnúkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions. You're lazing around on the deck of the ship when you see something whitish-gray covering the horizon. Like in a horror movie or your worst nightmare, this weird fog is nearing the vessel. It's infinite. You can't see where it starts or where it ends. Soon it makes the ship look like a grain of sand in a vast desert. That's when the realization hits. It's an iceberg, and your ship is likely going to repeat the Titanic's fate. Now, all this is a very likely scenario, since the world's biggest iceberg, A23A, is on the move again after months of spinning in a huge water vortex. And it's actually the second time in just a couple of years that this massive chunk of ice has broken free. The first time was in 2023, when the berg went wandering around after being stuck on the seafloor for a staggering 37 years. The thing is huge, about 3 times the size of New York City. It also weighs nearly 1 trillion tons. The giant chunk of ice first broke off from Antarctica's Filsner ice shelf back in 1986, but instead of floating away, it got grounded on the seafloor just a few miles from where it started. Because of that, it melted much more slowly than most icebergs. In December 2023, A23A finally broke free and started to drift away from Antarctica. But it didn't get far before getting stuck again, this time near the South Orkney Islands. It got trapped in something called a Taylor column. That's a huge spinning water current that forms when ocean currents swirl around an underwater mountain. At one point, A23A was rotating around 15 degrees counterclockwise every day. Luckily, as of December 2024, the iceberg escaped the Taylor column and is now slowly moving again. Researchers are super curious to see if it'll follow the same path as other giant icebergs that have broken off from Antarctica, or if it'll find its own unique way. Such enormous icebergs, such as A23A, release nutrients into the water as they melt, and it can actually create hotspots of life in parts of the ocean that are usually pretty empty. But there's still a lot we don't understand about how the size, shape, or origin of the iceberg might affect that process. So, to figure it out, scientists have been collecting water samples from the areas A23A is expected to pass through, and they'll keep collecting samples as it drifts along. Hopefully, it'll give us a better idea of how massive icebergs like this one influence the ocean around them. By the way, the glacier our monster of an iceberg was once part of could be very, very old, literally ancient. In Antarctica, the oldest glacier ice might be close to 1 million years old. Over in Greenland, the oldest glacier ice is more than 100,000 years old. And in Alaska, the oldest glacier ice ever recovered, found in a basin between Mount Bona and Mount Churchill, is only about 30,000 years old, a mere child. At the same time, in a typical Alaskan Valley glacier, it only takes about 100 years for newly formed ice to travel through the entire length of the glacier. For something like Bering Glacier, which is Alaska's largest and stretches over 140 miles, the ice can move through the whole thing in less than 400 years, and that's a lot of movement for such a massive glacier. Now let's move on to Iceberg Alley, a stretch of the Atlantic Ocean that runs from the Arctic to Newfoundland. If you want to see as many icebergs as you can, that's the place to be. Tons of icebergs float through this place every year. Most of them come from Greenland. In spring and summer, big chunks of glaciers break off and get carried by north-south currents through Baffin Bay into the Labrador Sea, where they eventually melt. Some icebergs also come from Canada's shoreline, traveling through the Davis Strait and into the Labrador Sea before drifting along Newfoundland's eastern and western coasts. These massive ice chunks are really old too, about 10,000 years. Every year, about 400 to 800 medium and large icebergs pass through Iceberg Alley. How fast they drift depends on their size, shape, currents, waves, and wind, but the average speed is less than a half mile per hour. Now, there are 6 types of icebergs that make their way through Iceberg Alley. Tabular icebergs are flat slabs of ice, much wider than they are tall. Blocky icebergs have steep sides and sharp angles, like cut-off pyramids. Wedged icebergs have one steep side and one sloping side. Dome icebergs have a rounded top. Pinnacle icebergs have one or more steep peaks sticking up. And dry dock icebergs are U-shaped with a hollowed-out section. They all look incredible. Comment below which is your favorite type. Anyway, as these icebergs drift south, the warmer water speeds up their melting, making them pretty unpredictable and sometimes dangerous. Nowadays, satellites help track medium and large icebergs to prevent accidents, but smaller icebergs can still be risky for small boats. One iceberg made headlines in 2018 when it got unusually close to the Newfoundland village of Fairyland. Pictures of the giant iceberg towering over the village's houses went viral. It got stuck in a 330-foot deep water, which turned out to be too shallow for its massive size. And now I'll take you on an unusual journey to the past to witness the birth of something beautiful and equally disastrous. Its very existence led to one of the greatest tragedies in history. Watch, an enormous chunk of ice is breaking off a glacier in southwest Greenland. It's made of snow that fell over 100,000 years ago, when mammoths were still wandering around the planet. The enormous iceberg starts its long journey. It stretches more than 1,700 feet in length and weighs 75 million tons. Despite its size, it's pretty peaceful and stays far away from ships and the busy transport routes near where it was born. But then, it starts floating south, much farther than most icebergs ever get. Usually, icebergs like this melt way before they reach such warm waters. Out of the 15,000 to 30,000 icebergs that drift away from Greenland's glaciers every year, only about 1% make it all the way to the Atlantic. So the fact that this iceberg keeps going and reaches over 5,000 miles south of the Arctic Circle by April makes it truly unique. Even after months of melting, this block of ice is still incredibly massive. It weighs around 1.5 million tons, which is almost twice as much as the Golden Gate Bridge. Above the water, its visible parts tower more than 100 feet high. But like most icebergs, the majority of it, about 90%, is hidden below the surface. The iceberg story takes a tragic turn on April 14, 1912, when, guess what? Yep, it comes across the ocean liner Titanic. The ship is about 370 miles from Newfoundland in the North Atlantic Ocean when the iceberg seems to appear out of nowhere. The crew doesn't spot it until just minutes before the crash. Why don't they see it sooner? That's a good question. Now, most people imagine icebergs as tall, bright, white chunks of ice, maybe even covered with snow. But in reality, icebergs come in all sorts of colors. Some are striped, patterned, or even have candy-like swirls, and they can also be black. There are two ways an iceberg can turn black. When the ice is extremely pure, with no bubbles or cracks, then it absorbs all the light instead of reflecting it, making it look black. Or a volcanic eruption can cover a glacier in ash. If ice from that glacier breaks off, it can have a dark or black color. Now, scientists still aren't sure why the Titanic's iceberg looked dark, or even if it really did. But one sailor who was on the lookout in the crow's nest said it seemed black. Another described it as gray or dark gray. One theory is this iceberg could have been a blackbird, which forms when the top part melts, causing the iceberg to roll over. If the bottom is smooth enough to absorb light, it looks dark. But even if the iceberg wasn't truly black, nighttime could have made it much harder to spot. Icebergs don't reflect much light, especially if they're jagged or vertical. They end up blending into the dark, shimmering ocean. Without radar, icebergs at night are incredibly hard to see, which is probably why the Titanic's crew didn't notice it in time.
You're down in one of those polar seas where the Brinicle, eerily called the Finger of Death, is born. It's a strange, almost otherworldly place, the deep ocean, where light barely reaches. Everything down there seems to have adapted to survive in darkness and intense cold. But even those truly hardy creatures aren't ready for what a Brinicle can do. When that briny, supercooled water starts dripping down, a ghost story begins. The formation of these Brinicles is a fascinating process, like an underwater science experiment happening in real time. We know that when seawater freezes, it doesn't freeze like fresh water. Because of all the salt in it, it has to push out impurities to form the pure ice that floats at the top. This means the salty water, or brine, ends up trapped in channels and pockets within the ice. When it sees the light of day for the first time, a Brinicle resembles a pipe of ice reaching down from the underside of a layer of sea ice. At first, a Brinicle is very fragile and its walls are thin. But the continuous flow of colder brine supports the growth of the Brinicle. It also prevents it from melting. Otherwise, this process would be inevitable, caused by the Brinicle's contact with less cold surrounding water. As the ice accumulates and the walls become thicker, the Brinicle becomes more stable. Over time, the brine trapped inside gets squeezed out through tiny cracks, dripping down in this cold, heavy plume. Once that cold brine starts flowing downward, it begins freezing the seawater around it into a sheath of ice. That's why, instead of melting as it hits the water below, it forms this icy casing that protects it, helping it grow longer and stronger. The Brinicle keeps moving forward inch by inch, and this crazy downward spiral is almost unstoppable. And when it touches down on the seafloor, that's when the trouble begins for anything living nearby. Imagine being one of those creatures on the seafloor, maybe a sea star or an unsuspecting urchin just trying to make it through the day. and all of a sudden, you see this icy tentacle nearing you. It isn't just some cold water coming down. It's basically a net of ice moving down and spreading out. There's no escape, no way to predict its coming, and no chance for survival. It's a slow-motion natural disaster in action. When a brinicle reaches the seafloor, it continues to accumulate ice while the surrounding water freezes over. The brine keeps traveling across the seafloor in a downslope direction. Once it reaches the lowest possible point, it stops and pools. But don't let the danger distract you from how beautiful brinicles are. Well, in their own creepy way. They look like something you'd see in a dream. Elegant, twisting ice tubes reaching down, perfectly symmetrical, and totally random. Filming a brinicle is no easy task because they're delicate when they first form. Just the motion from a nearby current or a sudden change in temperature can snap them off, ending the show before it really starts. So, scientists who managed to capture brinicles on film in 2011 actually got incredibly lucky. It was the first time the world got to see this icy finger descending and freezing everything it touched, and it changed our understanding of polar ecosystems. Brinicles can reach quite impressive sizes. Sometimes they can stretch for several feet. Their size depends on the conditions of the water and ice above. The slower the water movement and the colder the temperature, the bigger and stronger a brinicle can grow. But if the water's too deep or if there's too much movement in the current, the brinicle is likely to break apart. It needs just the right balance to survive long enough to touch down and freeze over the ocean floor. For creatures living on the seafloor, brinicles are like invisible booby traps, only instead of avoiding a net, they're avoiding an expanding ice cage. Starfish and sea urchins might not have big brains, but they have a basic survival instinct to crawl away from danger. Sadly, with brinicles, they're usually caught completely off guard. One second they're minding their own business, the next, an icy sheet is closing in around them, trapping them where they are and freezing them almost instantly. It's hard not to feel sympathy for these creatures, right? You watch footage of a brinicle in action and you see a starfish just stopping. One moment it's moving slowly along the sand, and then it's frozen in place, totally helpless. It's like watching a train wreck in slow-mo. Luckily, brinicles present danger only to smaller marine life forms like sea urchins and starfish. Bigger animals like seals or whales, or humans who happen to go diving in the ocean at the frigid poles, brinicles are totally harmless. At the same time, for scientists, this tough natural phenomenon offers a fascinating insight into how life adapts, or fails to adapt for that matter, in extreme environments. And it gets even better. A brinicle might just be the perfect setup for life to begin. Researchers are now looking at these super salty ice tubes as not just fatal traps, but potentially as sources of life. This theory isn't just science fiction, it's rooted in actual research. Here's how it goes. The brine channels in sea ice are full of tiny, confined spaces. Those are exactly the kind of places where chemicals can get trapped, concentrated, and start interacting in interesting ways. It's like setting up a mini-lab where the building blocks of life can come together and create something new. Scientists think this process of salt rejection in sea ice could have actually helped the first bits of life appear. Some researchers even think that this process might be happening right now on icy moons like Europa, Ganymede, or Enceladus, where there might have been frozen seas beneath thick ice layers. Just imagine it. Brinicles forming in other worlds of our solar system, laying down the foundations for extraterrestrial life, and all thanks to the same icy process that creates these fingers of death here on Earth. One way scientists describe brinicles is by comparing them to chemical gardens. Have you ever done one of those experiments where you mix metal salts into a solution and watch them produce plant-like structures? Well, you can observe a similar chemical process when a brinicle is in action. In the cold, saline-rich brine of a brinicle, certain reactions could kick off to create amino acids or other building blocks of life. It's wild to think that something so dangerous could have also helped shape our world. Or could be creating other forms of life elsewhere. In both cases, whether on Earth or another planet, these icy chemical reactions might be the first step toward the formation of simple life forms. It's a kind of alchemy, where ice and salt water mix to create something more than the sum of their parts. This is one reason why scientists are so eager to study brinicles. Each one could hold a tiny clue about how life begins, survives, or fails under extreme conditions. Something as mesmerizing and weird, but at the same time simple as brinicles, hints at bigger questions. How did life start on Earth? What are the conditions needed for life to survive in extreme environments? Could icy structures like these exist in other parts of our solar system or beyond, creating similar conditions that might one day give rise to alien life? As much as they look like a silent threat reaching out from the ice, brinicles are also reminders of how beautifully complex and interconnected our world is. They may seem like simple fingers of ice, but they hold secrets that touch on everything from ecology to chemistry to the origins of life itself. So next time you hear about the ocean, remember that deep below in the darkest, coldest waters, something incredible and a little bit terrifying is happening right at this moment. In 2020, strange signals from deep beneath Antarctica sent shockwaves through the news. Within days, headlines exploded. NASA had found a parallel universe where time runs in reverse. But what really happened? And what did scientists actually detect? Well, this story is a case of madness, misunderstood experiments, and the human need to believe in mystery. Even today, every few months, someone reposts a headline screaming that NASA found a parallel universe in Antarctica. A universe where time flows backwards, and people believe it. But no, NASA didn't find a mirror world under the South Pole, or some sort of a backwards reality where people age in reverse or speak in rewound sentences. They did find something curious, though. Here's what actually went down. Scientists were flying a strange-looking instrument over Antarctica called ANITA, short for Antarctic Impulsive Transient Antenna. ANITA is a machine that floats over Antarctica, basically a giant balloon with antennas. It listens for tiny space particles called neutrinos. Neutrinos are super small and ghost-like. They have almost no weight and go through stuff like it's not even there, even entire planets. Usually, these neutrinos come from space and rain on Earth from above. Most neutrinos, the common low-energy ones, just fly right through the Earth like it's air. They're like tiny bugs flying through a chain-link fence. There are some very high-energy neutrinos, though. They're super rare and they interact a bit more often with matter, and they can get blocked. If high-energy neutrinos hit something dense enough, like the rock and metal inside Earth, they might finally bump into a particle and get absorbed. That's more like fast tennis balls that hit the fence once in a while. Low-energy neutrinos, which are everywhere and pretty harmless, are pretty undetectable. But these high-energy guys are exactly what ANITA can detect. When they slam into ice, they send some radio waves that are easy to listen to. This faint radio signal is called the Askaryan effect. And yep, that's exactly why ANITA is flying over Antarctica. That's because the ice is pure, dry, and quiet. It's perfect for catching those rare signals. So, what did ANITA detect? It detected something rising up from below the ice, like a high-energy neutrino coming from the Earth. What? Okay, let's think logically. Maybe it started somewhere in the north, traveled all the way through the Earth, and popped out the other side. Still, that's super weird. That's not supposed to happen. Neutrinos with that much energy should have been stopped inside the planet. Like we said, get absorbed. So, scientists caught a little bit of a brain bug. That shouldn't be possible with our current physics. unless something we don't understand is going on. And when you're faced with something bizarre, you explore all options, even the wildest ones. The nightmare began. A group of researchers published a paper suggesting that this strange signal might make sense in a CPT symmetric universe. CPT stands for charge, parity, and time. These are basically three ways to flip the universe. Charge means swap all particles to their opposites. For example, swap electrons, the guys with the negative charge, with positrons, their antimatter twins with the positive charge. Parity means mirror the universe, literally like looking at it through the mirror. Left becomes right and right becomes left. And time, of course, means run time backward, like rewinding a video. Now, there's a big rule in physics called CPT symmetry. It says that if you change all three of those things at once, the laws of physics should still work the same. This is kind of insane, but if you took the entire universe and swapped matter with antimatter, mirrored it, and reversed time, it would still follow the same physics. Why is that? Well, in our universe, an electron bumps into a positron, and they annihilate into photons. Cool! Now take that, mirror everything, and what do you get? Well, photons spontaneously turn into a positron and an electron, but mirrored and reversed. It's still the same physics, even if it's backwards. The equations still check out, so nature thinks this is valid. So here came the crazy part. Some physicists thought, what if the Big Bang created two universes? One is ours, made of normal matter going forward in time. The other is a mirror twin, made of antimatter, going backward in time from our perspective. This doesn't mean that someone in the other universe feels time going backward. To them, time flows forward, just like it does for us. But from our point of view, they're moving from our future toward our past. And vice versa. To them, we're weirdos who move backwards. And if both universes are exact CPT mirror images of each other, that would mean same physics, same rules, just symmetrical. Same rules, just symmetrical. This isn't some crazy sci-fi theory, even if it sounds like it. It helps explain weird physics mysteries. For example, why there's so much matter in our universe, but not much antimatter, even though they were supposed to be created in equal proportions. Or why the universe is so symmetrical and balanced in some strange ways. So, coming back to the neutrinos, some scientists suggested that maybe those upward flying particles could be coming from that CPT mirror universe, poking through into ours, like a crack between two symmetrical realities. And if you look at it like that, this is quite a wild take. It's speculative. It's not proven. It's more of a cool thought, but the media immediately blew up. They ran a piece with the headline that said we found proof of a parallel universe going backwards in time in Antarctica. And all the other big tabloids picked it up. They made it sound like NASA had actually found a parallel universe. Time travel is real. Multiverse is confirmed. Meanwhile, people who worked directly on Anita immediately caught brain damage. They tried to jump in to say that's not what happened at all. They explained that the signals were unusual, yes, but there were plenty of normal explanations that didn't require rewriting the laws of physics. It could even be just an experimental error. Maybe an unusual particle behavior or gaps in how we model neutrino interactions. Of course, no one listens to experts about what experts discovered. And once an idea like that hits social media, it becomes nearly impossible to put back in the box. But that also doesn't mean that the multiverse definitely isn't real. Far from it. Physicists are still exploring the concept and assume that some of those potential universes, if they exist, could have different laws of physics. One idea, called the many worlds theory, comes from quantum physics. It says that every time something can happen in more than one way, like a particle moving or a decision being made, all those possibilities actually happen, but in separate universes. So there could be endless versions of reality, each slightly different, branching off from every event. Maybe in one universe, dinosaurs never went extinct. Maybe in another, you never sent that embarrassing text. Another theory is called the bubble universe theory. After the Big Bang, the universe expanded incredibly fast in a process called inflation. Some scientists think that inflation never fully stopped and is still happening in some regions. That would mean new bubble universes are constantly forming, each with its own version of physics. Our universe would just be one bubble in a giant cosmic sea of others. The third idea is about shadow matter. Dark matter is invisible, but its gravity affects the universe. Some scientists think it could be made of particles similar to the ones that make up regular matter, but they're just hidden from us. This mirror, or shadow matter, could form entire invisible galaxies and even life, all existing right alongside us. Maybe we just can't detect it in any way except through gravity for now. But in physics, all of those are just theories, mathematical possibilities. We have no direct evidence that it's real. If we ever find one, though, let's now hope it won't be the boy who cried wolf scenario.
Ooh, you're diving into the dark and icy waters of Antarctica. The eerie blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well, off the western coast of Australia and near New Zealand. They recorded similar but higher pitch signals, which they named bio-goose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on bioduck and biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, Researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike bioduct, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound source was a giant sea monster, kraken, or some other creature. The hype around the bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet Upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it. The largest volcanic region on Earth is not in Africa or Japan, but under the ice of Antarctica. Scientists found 138 volcanoes in its western part, and if they decide to go wild, you'll surely notice it. They could melt huge amounts of ice that will move into the ocean, raise its level, and make our planet uninhabitable for humans. But before you pack your things to fly away to another planet, hear me out. Only 2 of the Antarctic volcanoes are officially classified as active now. And it would take a whole series of eruptions, decade after decade, to seriously impact the whole world. Mount Erebus, one of the 2 Antarctic volcanoes currently in action, proudly bears the title of the world's southernmost active one. It has been continuously erupting since at least 1972. It emits plumes of gas and steam and sometimes even spews out rocks, and scientists call it Strombolian eruptions. One of the coolest features is a lava lake in one of its summit craters, with molten material on the surface. Such lakes are rather rare because they need certain conditions to make sure the surface never freezes over. The second active volcano is Deception Island, a horseshoe-shaped landmass. It is the caldera of an active volcano that last erupted over 50 years ago. Scientists who monitor it say it shouldn't go wild anytime soon. Antarctica also has plenty of fumaroles. Those are volcanic vents that release gases and vapors into the air. In the right conditions, they can spew out enough stuff to build fumarolic ice towers up to 10 feet tall. Scientists keep an eye on the Antarctic volcanoes with seismometers that detect when the Earth starts trembling from volcanic activity. Sometimes they also use more complicated tech, but it's all really challenging because of how far away this polar region is and how tricky it is to get there. That's why no one can predict when one of the continent's volcanoes that are now sleeping might erupt. We can guess what this waking up would look like if we analyze the events from nearly 20,000 years ago. So, shall we? One of Antarctica's sleeping volcanoes, Mount Takahe, had a series of eruptions and spewed out a good amount of halogens rich in ozone back then. Some scientists say these events warmed up the southern hemisphere. Glaciers started to melt and help finish the last ice age. For these events to repeat, we'd need a series of eruptions with substances rich in halogens from one or more volcanoes that are now above the ice. It's an unlikely scenario, but since it already happened in the past, it's not completely impossible. As for volcanoes hiding under a thick layer of ice, it looks like their gases would hardly make it to the atmosphere, but they would be strong enough to melt huge caverns in the base of the ice and produce a serious amount of meltwater. The West Antarctic ice sheet is wet and not frozen to its bed, so this meltwater would work as a lubricant and set the overlying ice into motion soon. The volume of water that even a large volcano would generate in this way is nothing compared to the volume of ice beneath it. So, a single eruption wouldn't make a difference. But several volcanoes erupting close to or beneath any of the western Antarctica's big ice streams would. Those ice streams are rivers of ice that take most of the frozen water in Antarctica into the ocean. If they change their speed, then bring unusual amounts of water into the ocean, its level will rise. As the ice would get thinner and thinner, there would be more and more new eruptions. Scientists call it a runaway effect. Something like that happened in Iceland. The number of volcanic eruptions went up when glaciers started to recede at the end of the last ice age. So, it looks like, for massive changes, several powerful volcanoes above the ice with gases full of halogens need to get active within a few decades of each other and stay strong over many tens to hundreds of years. Antarctica stores around 80% of all the fresh water in the world, and if they melted all of it, global sea levels would rise by almost 200 feet. And then we'd have to look for a new planet to live on. But this again is an unlikely scenario. It's more likely that the eruptions under the ice will lubricate ice streams and seep water into the ocean. But it wouldn't be the end of the world. A super strong, super angry supervolcano could do it though, and it has already happened in the past. Over 200 million years ago, the world went through a major makeover with not one, not two, but 4 massive volcanic eruptions in huge pulses. The supervolcano called Camp had been erupting over and over for 600,000 years. It all happened in Wrangell, a large chunk of land that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. And it wasn't the lava or the volcanic ash that ruined the environment. The eruption made carbon levels skyrocket. The planet would never be the same again. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in Asia to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels. It made the atmosphere toasty, and the rain poured down. So the bad news is, another eruption like this could happen. The supervolcano beneath Yellowstone National Park has been sleeping for nearly 70,000 years. But if it wakes up, it would be many times more catastrophic than the eruption of Mount St. Helens in 1980. It's considered the most disastrous volcanic eruption in U.S. history. It followed 2 months of earthquakes and injection of magma below the volcano that weakened and destroyed the entire north face of the mountain. The eruption column went 80,000 feet into the atmosphere and spread ash over 11 U.S. states and several Canadian provinces. The last Yellowstone eruption was 1,000 times greater than that. The ground above Yellowstone sits on a hot spot made of molten and semi-molten rock called magma. This magma stuff flows into a chamber beneath the park, about 4 to 6 miles down, making the ground puff up like a balloon. But then, as it cools down, the ground goes back to its usual state. Volcano watchers have been keeping an eye on this for a century. They noticed the ground lift up about 10 inches around 20 years ago, but since 2010, it's been going back down. The experts say we have no big eruptions on the horizon, so doomsday isn't coming anytime soon. But there's some underground activity going on lately which keeps us interested. Since humans haven't been around to witness every little thing Yellowstone does, it's kind of tough to say for sure what's brewing down there. Yellowstone has had some epic eruptions within the last couple million years. They happen like clockwork, with gaps of 600,000 to 800,000 years between them. The last big one was around 640,000 years ago, and it basically reshaped the entire landscape, spreading ash and debris as far as Louisiana. You can still see the aftermath of the last big eruption in the Yellowstone caldera today. Experts say a massive eruption like the last one is an unlikely scenario. We're more likely to see eruptions of steam and hot water or lava flows. When and with what force it will wake up remains a mystery to scientists.